Yes, I'm very happy to be here this morning. Yeah, so I'm Adeyinka by name. I'm going to be taking us on data analysis. Then later you may want to considering upscaling to data science, where you're talking about machine learning, predictive modeling, and all these deep learning and stuff. Then you can now decide I still want to go further to artificial intelligence. Let's understand the basics of data analysis. If I should ask us now, you want to learn data analysis? What is data analysis? What is data analysis? I need us to respond. Anybody? What is data analysis? Oh yeah, please.
Process of drawing insights and data.
Okay, yes, very good. It's the process of drawing insights from data. Good. Any other person?
The process of gathering data and dealing with data in order to make an informed decision.
Excellent. Excellent. That's beautiful. So let me also do my own too. It's the process of converting data to information for the purpose of making decisions in an organization, which can be an health institution, a university where we have scientists doing research, an industry, a manufacturing firm, anywhere. That is what we call data analysis, converting raw data, raw facts to what? Information for the purpose of what? Decision making. In an organization, it has to be at least in a setting. So, okay. So from there, I would also like to ask us a question. What is data? What is data? I've said it. If you read my lips, yeah. What's data?
Data is any piece of content that you can extract information.
Okay. Any piece of content is okay. Yes. Any piece of content that you can use to extract information. Yeah, using our definition again. Of course, that's correct. Then data are raw facts. Raw facts. The outcome of measurement is data. So values given to a particular phenomenon is data. All right. Okay. Now, can I ask us a question? What is measurement? Measurement. Very simple question. And I'm expecting PhD answers. I mean, let me start from you, because it looks like a PhD student. Measurement. Anybody that wants to try? Yeah, it's a very simple question. From back then, we have been doing 60 seconds, maybe 1 minute. So it's not something difficult. So let me just define measurement as the process of assigning value or a score to an observed phenomenon. It's the process of assigning a value or a score to an observed phenomenon. Very important. Everything we are doing in data analysis starts with what? Measurement. If there is no measurements, just like our definition, there won't be data. If there is no measurement, there will not be data. We won't be observing anything. So, we have what we call the scale of measurement. Scale of measurement. How many scales of measurement do we have? How many scales of measurement do we have?
Mr. Head to write
Okay, we have 4 scales of measurement. What are they? Those online, please be typing your responses because I'll be asking lots of questions, and you too should contribute to the question and answer. So we have 4 scales of measurement universally. We have only 4 scales. And what are they? We have the nominal scale of measurement. We have the ordinal scale of measurement. We have the interval scale of measurement, and we have the ratio scale of measurement. Nominal scale of measurement. What's nominal simply means names. Names. So it's the most primitive scale of measurement. When we talk about primitive as the lowest scale of measurement, when I say primitive, is the lowest scale of measurement. That means names the major attribute of that particular scale of measurement is that number 1 is in form of classes. Then the second part is that there's no sense of order, no order in the measurement. When a measurement doesn't have order, then we say it's what? Nominal scale of measurement. There's no sense of order in it. Let me give us examples. Okay, let me say names of persons. I said nominal means name. Okay, my own name is Yinka. Your name, huh? Bukola. Can we say that Yinka maybe because Yinka starts with Y and Bukola starts with B? That means Yinka is bigger than Bukola? No, there's nothing like that. So they are just names, classes without any sense of order. Blue, yellow. Can we say blue is greater than yellow? No, they are just different classes, different entities without any sense of order in it. So that is what the nominal scale of measurement. We have different things like Oshogbo, Ibadan. If we are not looking at other factors, we can't just say because maybe one is O or I or something. No. So they are nominal measurements. So, and the list goes on and on like that. Then we move to a more advanced scale of measurement, which is the ordinal scale of measurement. When we talk about the ordinal scale of measurement, we are talking about still a variable in form of classes, but then now the root word of ordinal is what? Order. That means a sense of order has been introduced to the measurement. Still in form of categories, but now with a definite order. Let's give examples. If we say that, okay, somebody is a first-class student, another person is a second-class upper student, another one, there are different classes, but then we know that first class is better than second class. So there is a sense of order in the arrangement. Or grades, like somebody had A1, B2, B3. They are different classes, right? But then we know that one is preferable to the other. That's ordinal scale of measurement. The nominal scale, we said there's no order. Now we said a sense of order has been introduced. But one thing we should take note of is that both the nominal and the ordinal scale of measurement belongs to a type of variable known as categorical variables. Both the nominal and the ordinal scale of measurement belongs to a type of variable known as the categorical variable. Okay. Let me go to the third one, the interval scale of measurement. Interval scale of measurement that has a specific value. It's not in form of category. It's not in form of numbers. Are we getting it? It's in the form of a specific figure. The measurement has a specific figure attached to it. But there is a problem with interval scale of measurement, and that's what we call arbitrary 0 point. Are we together? Arbitrary 0 point. And what's the meaning of arbitrary? Arbitrary means false, not true. arbitrary 0 points. Let me give us a case in point. Let's consider the case of temperature. If I should ask us which temperature is the minimum temperature, 0 degrees Celsius. And that's person, I'm hearing something else. Minus what? Or just minus? I'm with you. I said, what's the minimum temperature possible? We should have an exact figure for that. Or there's no exact figure. Temperature can go on and on and on, as low as possible, as low as minus 1,000 degrees C, minus 1 million degrees C. I'm not the one that said that, too, because some of those of us online and those that will be listening to the class later, the minimum temperature possible is minus 273 degrees C. Minus 273 degrees. That's why I said arbitrary 0. That means that the 0 degrees C is not the minimum possible temperature. So which type of 0 is that one? Arbitrary false 0 degrees C, because it's not the starting point. The real starting point when we talk about temperature in degrees Celsius is minus 273 degrees C. Because at minus 273 degrees C, the volume is also what? 0. Now, temperature in degrees Celsius is which scale of measurement? Interval scale of measurement. But then, this same temperature, it's not only temperature, we have the IQ, we have even days of the week, like Monday now. Monday is the first day of the week, right? But before Monday, we had Sunday, we had Saturday, so that means it's not actually the starting point. So it's an interval scale of measurement. We have January like that. So when the starting point is not actually, the 0 point is not actually the starting point, like 0000 AM. We had 11:59 before that. So which scale of measurement is that? That's interval. So, but then we also have the ratio scale of measurement. Ratio scale of measurement is when there is instead of the arbitrary 0, we have the absolute 0. Absolute, or what we call the true 0 point. Like a case in point now is, let me still use the same temperature. Temperature in Kelvin scale or in the Kelvin units. The minimum temperature in Kelvin is what? 0 Kelvin. So it's not possible for a temperature to be less than 0 Kelvin. That's when you convert from degrees Celsius to Kelvin. So the absolute minimum temperature ever possible is what? 0 K. So temperature in Kelvin unit now is which scale of measurement? Ratio scale of measurement. Let's look at weight. The minimum weight possible is what? 0 kg. So weightlessness is 0 kg minimum. Now, that's which scale of measurement? Ratio scale. Distance. It's not possible for distance to be negative. It is not possible. The best you can have for distance is 0, either centimeters or meters or whatever unit, 0. So which scale of measurement is that? Ratio scale of measurement. Now let's take note of this. Both the interval scale of measurement and the ratio scale of measurement belongs to a type of variable known as what? Numeric variable. Numeric variable, very important. Numeric variable. Okay, all right, that's good, very good. Freeman, yeah. Now let's talk about variables. What's a variable? Anybody? What's a variable? Who is helping us, please? What is a variable? Anybody that want to attempt? These are the fundamentals when it comes to data analysis. So if you don't know variable, you're not a data analyst. So what's a variable?
Hello. Hello.
Yes, sir.
Yes, variable, anything that can change or
Very good. Yes, because somebody, I think I watched one of resource videos too that talked about it. Resource videos. Have you been watching your videos? Yes, and those are, I was expecting all this response, anything that can change. I had it in the video. I watched the video, I had it. The containers of value, the store value of data. Why are we not saying anything? So a variable is anything that varies, anything that can change, anything that can exercise change in magnitude or direction is a variable. A variable is what? Anything that varies. I think that can change. So that is a variable. Anything that can change is a variable. Now, we have what we call types of variables. Good, very good. Yeah, I said that. Yeah. Any other one? I've talked about two today. Numerical variables, yes. Any other one? Huh? Strange, yes, we call those data types. Data types. So I will not be going to strange now. I just want to talk about the types of variables. Now, under types of variables, we have different classifications. We can classify type of variables in different ways. The first classification I'll be considering is categorical versus numeric variable. Categorical versus numeric variables. What is a categorical variable? Any variable that's in form of classes, in form of categories, is what? A categorical variable. Once you're in form of different classes, either you are nominal or you are ordinal. Ordinal, all these strongly agreed, neutral, disagree. Likert case, they are categorical variables. They are in form of classes. Now, gender is an example of categorical variable. Male, female. Place of residence, rural, urban is a categorical variable. Ibadan, Ife, Oshogbo, categorical variable. Any variable that is in form of classes or range of values, like age group. Here's the age group now. We can now decide that 0 to 4 is a categorical variable. 5 to 9, like that. Blood pressure. Yes, blood pressure is a numeric variable, but you can convert it to categorical variable. We can have high blood pressure in form of classes, moderate blood pressure, low blood pressure. Of course, blood group 2 is categorical. I think we have AA, if I'm correct, AS. So that's that. Now, all right. We have the other part, which is the numeric variable. Those are variables in form of numbers, in form of figures, exact figures, not range of values. Let's take note of that. If like age now, age is a numeric variable. What's your age? Say it. But then if we ask that what's your age group, that means it has been converted to categorical. Very, very good. So age, not only age, number of students in a class is a numeric variable. Years of schooling is a numeric variable. Other examples, number of children is a numeric variable. Any other one? Huh? Height. weight, body mass index. Which other one? Even blood pressure. All of them, they are numeric variables. Numeric variables. Let me ask you some questions. Pregnancy status. Is it numeric or categorical? Good. Contraceptive use. Is it numeric or categorical? Contraceptive use. Age at
Categorical.
contraceptive use is not numeric. It is categorical. Either you are using or you are not using it. Age at marriage. Is it numeric or categorical? Age at marriage.
Categorical.
Age at marriage is not categorical. It's numeric. Which age did you marry? What's categorical about? It's numeric. Age at first sexual intercourse. It's numeric, not categorical. It's not categorical. So different things like that. So those are examples of numeric and categorical variables. Now let's go to another classification of types of variables. We have the independent versus dependent variables. Independent versus dependent variables. Independent. Okay. No, don't worry. Don't worry. I think on the portal, I saw data visualization. Was that where you started? So the first thing we are going to learn is I'm looking at us learning SQL. Yeah. Then Python. I can see Python too. Not on this resource, those video resources. I think they are not comprehensive enough because the scheme that I was given contains some things that are not on the portal. Like Python, I didn't see Python, although Python is under data science. In the one I watched.
Actually, Python is under data science. I'm attached to all SQL Africa. So
Okay.
whenever I see that those guys will say data science.
Yeah, same thing.
Then
Yes.
it's ask the class.
But then we are going to teach you Python here.
Oh, that's good.
Yes, because it's in the curriculum, but it's not in the videos under the resource, the online resource. But whether you like it or not, I will teach you Python. So that, and then I will teach you database management. If we have time, I'm not sure we have time. I would have said I will teach you data visualization using Power BI, Tableau, but I'm not sure there will be time for that. But then once we are learning Python, we'll be learning Matplotlib, where you can use Python for data visualization. There is nothing you cannot do on Python. So let's leave that. Now let's continue. This is the foundation of data analysis. The statistics. Data means statistics. So if we don't understand this part, we are nothing less than a computer scientist. So it's the mixed bag of computer science and maths that form data analysis. And I said that if we want to further to data science and AI too, they're in the same line. So now, okay. Yes. So the next one, where are we? We were discussing independent versus dependent. Very important you get this. The equation of a straight line is what? Yes. Yeah. Y equals to mx plus c. Yeah. Where y is what? Y is the dependent variable. X is the independent variable. X is the independent variable. Y is the dependent. M is the gradient. And C is the intercept or constant. So M is the gradient or slope. We also refer to it as slope. So now that's the equation of a straight line. But what led to that? Y is what? The dependent variable. That's what we want to discuss now. Then X is the what? Independent variable. That's what we want to talk about now. So what is what do we mean by dependent variable? When we talk about dependent variable, it means a variable that is being manipulated in a research process. That's the easiest way to put it. But there's another variable that is like a factor causing it to happen. There's a cause and effect relationship. Another word for dependent variable is response variable or outcome variable. So it's just the result or the impact of another variable. So it's the variable that is being impacted upon in a process, either a business process or a health process or research process. So different processes like that. So that is what dependent variable. I'll give us examples. Then we have the independent variable. Independent variable is the variable that is the causal variable. I mean, the one that is like the factor, the variable that is explaining the dependent variable. So another word for the independent variable is explanatory variable. And like the other class, somebody also called it the predictor. So the predictor variable is the what? Independent variable. I gave an example of when they used to teach us Yoruba in school then, in secondary school. I don't think we did Yoruba in the university, secondary school. So they said, I don't know, how many of us are Yoruba? Okay, not all of us. Now let me switch to English because of those that are not Yorubas. There is something they call object and there is something they call subject. Subject is the one that is performing action in a sentence, while the object is the one receiving the action. So that the object is what now? The dependent variable, because the one receiving the action, while the subject is the independent variable performing the action. So the one performing the action now in the research process is what? The independent variable, is the explanatory variable, is the variable that is manipulating the dependent variable. Let me give us examples because I believe we understand it better with examples. What's the impact of age at marriage on number of children? What's the impact of age at marriage? Or is there any impact? Does number of children depend on age at marriage?
Yes.
It's a research question. No definite answer until we carry out the research. But how many variables are there in that question? 2, right?
Two
And
variables.
good. What are they?
Age at marriage and number of children.
Excellent. Age at marriage, then number of children. Those are the 2 variables there. Does level of education, what's the impact of level of education on occupation, on income, on monthly income? So which one is the dependent and which one is the independent variable? Okay,
Level of marriage.
let's hold on, hang on a minute. We talked about age at marriage and number of children. Which one is the independent variable and which one is the dependent variable? That means age at marriage is what type of variable? Excellent. So when we talk about level of education and income, which one is the independent variable? No, level of education is the independent. Now, why the income is the what? Dependent variable. Excellent. Excellent. Very good. Now, we move over to another classification of type of variables. I believe we know that already. Dependent versus independent variables. Let's talk about count versus continuous variable. Count versus continuous variables. What do we mean by a count variable? Well, a count, before we can say that a variable is count or continuous, they must belong to a type of variable known as numeric variables. So they must be numeric before they are count or they are continuous. Now, under counts, count variables are variables that can only take up values in form of integers, in form of whole numbers. Like if they ask us now, what's the number of students in this class? It can only be in the form of whole numbers. Yeah, variables in the form of whole numbers. That's what count variable integers. Like in the other class, another person said, okay, is it the same thing as discrete variable? Yes. Count is the same thing as discrete variables, and they are under what? Numeric variables. Yeah. Now, the other one, continuous variables. They are variables that can take up values in form of fractions. They can take up values in form of decimals. That is what? Continuous variables. They are variables that between one value and the other, there can always be a middle value. Between 2 and 3 now, there are uncountable values there. Because by the time you start 0.1, 0.2, 0.1 million, you understand. So there are variables that can take up values in form of decimals. I hope we get the picture. Decimals, decimals of fractions. Yes. Okay, yeah. Nobody is chatting online again. Yes, okay. I think we are hearing their voice. Okay. All right. Then let's give examples of variables that are count, then variables that are continuous. Which variable do you see that this is a count variable? Huh? I had something just now. Okay. Age. Is age a count variable? Count? Okay. It can only be in form of whole numbers. That means you cannot see somebody that is 1.5 years old. It's not possible. 1 year, 6 months. 1 year, 8 months, and 3 days with 4 hours. It's not possible. It's possible. So age is not a count variable. Age is a continuous variable, not a count variable. Huh? Admission number, yes. It can only be in form of integers, right? Yes. Now, age, still on age. People will be wondering, why not integers alone? Age is not integer at all, or just in form of phone numbers. It depends on the time that the person was born. But then most people, there's this common mistake that when you are filling maybe a questionnaire or a form saying, what's your age? The question should have been, what is your age as at last birthday? That's the question. Age as at last birthday. That is what count. But age itself is not count. Age is continuous. So if they ask you that what's your age and you start telling them about the seconds and the yeah, you're actually correct. Okay. Good. Height is a very good example of a continuous variable. Height. We can be 4.57. That's a continuous variable. Weight is also continuous. Blood pressure is continuous. Temperature is continuous. Why? Because if they measure this temperature, maybe it's 37.5 or something. So it's a continuous variable. Now okay, which other thing? Examples of count variables. Years of schooling. Other 5, 6 years of schooling is count variable. Any other example of count? Number of children, parity. So they are count variables. Any other example? Because if you ask what's the number of children, you can't say 5.5. Or what's the number of students in this place? Say, huh? African. Half is not yet. Half. If you are not a baby yet, you are not yet a child. So if we can have fetus. So that's before live birth. But once there is a live birth, your age starts to count. That's when we have a living born. No, but without live birth, you are not yet part of us. So you are still in the other world. So you are still coming. All right. Now, because there can be stillbirth, and when there is stillbirth, we don't record it as somebody's, no, God forbid, we want to have that kind of experience. Now, the other one is another classification of type of variables. Okay, let's talk about dichotomous variables. What is a dichotomous variable? Dichotomous variable that has only two categories. Because di means two, and a categorical variable that has only two categories is a dichotomous variable. For example, let's say gender, male, female, place of residence at times too. We have rural and urban, depending on how you are measuring it. So then, which other dichotomous variable? Anybody that wants to give a suggestion? Yes or no is dichotomous? Yes. Huh? True or false? Yes. How about pregnancy status? Positive, negative. HIV status? Positive, negative. COVID-19 status? Or is it COVID-20? All right, positive, negative. So now let's talk a little bit more about types of variables. We also have the extraneous variables. Extraneous variables. Extraneous variables. I asked us a question the other time. I said, what's the impact of level of education on family income? Okay. You will agree with me that what determines family income is not only level of education. There can be some other factors apart from level of education. So all those other factors that affect our dependent variable, of which in that particular study or research process, we are not interested in considering their impact. There are so many factors that affect us, that affect our dependent variables, but not everything can be incorporated into the research study at a particular time. So all those other variables that are independent variables and affect the dependent variables, but for which we are not interested in looking at, are what we call extraneous variables. Extraneous variables. So they also impact, by the time we go into it, you will understand better. So we still have other types of variables. Now let's talk about okay, let's talk about statistics. What statistics? Because data, I said, is the same thing as statistics. So what statistics? Anybody online? That's not the definition of statistics. Branch of mathematics that deals with calculation. What are you calculating?
Hello, can I give it a try?
Oh yeah, please. Yes.
It's a process whereby we collect data, analyze, and make inference from it to either solve a problem or get information.
You didn't define it properly. You use
The
the word.
layman.
No, it's not a layman. You talked about collect data, inference the data. By the time you mention inference the data, you have neglected a particular arm of statistics that doesn't have to do with
Listen.
You get it?
Collect data, analyze data to make bring out how do I
Yeah,
to make
statistics. Yeah.
to be able to get
process of
specific information
collecting.
from analyze.
Yeah, you get it.
analyzing data,
Collect the
be able to
data.
make
Mhm,
analyze the data,
mhm.
and
You
be able
didn't talk
to
about data presentation or visualization. You
I
didn't
didn't talk
talk
about.
about interpretation. So those are the key areas when it comes to statistics. You collect the
Okay.
data collection, very important. If you like data cleaning too, it's also important. So then data analysis itself, then data presentation, that's the visualization. Then how about the interpretation? So of data, that's statistics. Then we have two types of statistics. Are we together,
Yes.
Kafayat?
Yes, yes, I'm here.
We have two types of statistics. What are they?
It's
This descriptive.
Okay.
Can't remember the second one.
I will imagine you mentioned it in your definition when you want to infer something.
Oh,
Inferential statistics. Inferential statistics. So we have the descriptive statistics and we have the inferential statistics. Descriptive statistics and the inferential statistics. What do we mean by descriptive statistics? All we did in secondary school are descriptive statistics. Starting with, and what do we use descriptive statistics for? To describe a variable. Like, okay, this particular variable, maybe it's variable age in a particular data that we have collected or we have accessed online. This variable now, what does it look like? Is it just like human being too? That this person now, what are the features of this person? Light in complexion. That's the same thing we do to variables or data too. This variable, is it normal? What's the mean of this variable? What's the minimum value in the variable? What's the maximum? What's the standard deviation? What's the variance? How does it look like on pie chart? How many people are, or how many percentage of people are between age 0 to 4? How many are between age 5 to 9? How many are between age 10 to 14? Like that. Bar chart, all the graphs, cumulative frequency curve, OGIV, measures of central tendencies, measures of spread, they are all what? Descriptive statistics. Everything we did that time is descriptive statistics. Graphs, they are descriptive statistics. Now we move to inferential statistics. That one is a bit on the high side. Now, that's when you start hearing about chi-square. You start hearing about correlation. You start hearing about regression. You start hearing about one-way ANOVA. You start hearing about ANCOVA. You start hearing about three-way ANOVA. You start hearing about MANOVA. You start hearing about random forest. You start hearing about binary logistic regression. You start hearing about multiple regression, multiple correlation. You start hearing about support vector machine. You start hearing about discriminant analysis, inferential statistics. So what do we use inferential statistics for? To infer. That was the word there, to infer, to make generalization about a population on the basis of a sample of that population. I'm trying to make generalization. For example, now somebody, maybe a white man, a researcher just entered Nigeria today. I want to perform a particular study in Nigeria. He doesn't need to go around the 36 states and capture all the entire population of Nigeria for that study. Just pick a sample, Ibadan, or let's say Oyo, Kano, Bayelsa, then which other one? Imo, just in the 6 geopolitical zones, and just maybe 100, a representative sample of the population, and you make inference, you infer, you make generalization about the population on the basis of a sample of that population. Very important. So that's where we have the different levels of analysis. We have the univariate level of analysis, we have the bivariate level of analysis, and the multivariate level of analysis. When we talk about univariate level of analysis, that's where we talk about uni means what? One. So that means there is only one variable in the research question. For example, say, what's the mean age of students in the class? What's the variable there? What's the mean age of students in today's class? Age, excellent. Age, that's the variable there. Or if you like, age of student. So that's what level of analysis is that? Because there is only one variable in that research question. So which level of analysis? Univariate level of analysis. But when you have something like what's the impact of level of education on income or number of children? Does level of education affect number of children? How many variables are there? Bivariate level of analysis. Why? Because there are two variables, level of education and number of children. What's the impact of age at marriage and number of and age at marriage and level of education and contraceptive use on number of children? Age at marriage, level of education, which other one? Contraceptive use and income on number of children. That's a multivariate analysis. Anything 3 or more is multivariate analysis. So that's that, 3 or more. Now let's talk about choice of appropriate statistic. Choice of appropriate statistical technique. This time around, I'll be talking only about inferential statistics. We know when to use, what's the name? All these univariate, descriptive statistics. You know, when you need your mean, when you need to draw a pie chart, although we may still go into it later. But today, let's talk about inferential statistics. How do you know when to use chi-square? How do you know when to use correlation? How do you know when to use regression? How do you know when to use simple linear regression? How do you know when to use Poisson regression? How do you know when to use binary logistic regression? How do you know when to use, there is what we call multinomial regression? How do you know when to use multiple correlation? How do you know when to use Poisson correlation? How do you know when to use parametric tests, non-parametric tests? So all this calls for us talking about choice or choosing the appropriate statistic. Now, you will appreciate what we discussed earlier about categorical and non-categorical and numeric variables. When you have two categorical variables in your bivariate analysis, two categorical variables, that is when you make use of chi-square. Chi-square, CHI. Yeah, chi-square. When you have two categorical variables in your research question or your business question, that's when you make use of what? Chi-square. Yeah, or chi-squared, if you like. All right. Let's give an example. What's the significance? Is there any significant association between level of education and any other categorical variable? Level of education and occupation. Is there any significant association between level of education? What you need to know is that level of education, is it categorical or numeric? It is categorical. Occupation, is it categorical or numeric? Categorical. I'm making use of chi-square for this analysis. You get it now? So once you are sure that that's the only two variables in that research question, so you make use of what? Chi-square. You make use of chi-square. Okay, then we move to another scenario. We call it scenarios. So it's possible that in your research question, it's not two categorical variables. We can have one categorical variable, one numeric variable, depending on the study. If what you're talking about is what's the impact of level of education on number of children. Number of children is not categorical, it's numeric. For level of education, there are two possible statistical techniques that you can use for that when you have one categorical and one numeric. That's another scenario. So it's either you are using independent sample t-test, or one-way ANOVA. I will tell us when to use one-way ANOVA and when to use independent sample t-test. Although I told you that the one has to be categorical and the other numeric. Now, when that categorical variable in that study has only two categories, that is dichotomous. Are we together? We make use of independent t-test. When the categorical variable, we say one is categorical, the other one is numeric. When the categorical variable has two categories, like gender, male and female, like a place of residence, rural and urban, like pregnancy status, positive, negative, COVID-19 status, vaccination status, all those things. When they have only two categories, we make use of independent t-test, or if you like, independent sample t-test. Then the second one is when the categories are more than two. Like the case of that level of education, we have more than two categories on that level of education. We have no formal education, we have primary, we have secondary, we have tertiary. In fact, we can define it another way, like diploma, BSc, masters, PhD. Do you understand? But definitely level of education is more than two categories. Are we going to use independent sample t-test for that? No. We are making use of what? One-way ANOVA. We are making use of one-way ANOVA for that. Are we getting it now? You can hear me now, sir. Very good. Let's talk about another scenario where we talk about two. It's possible that the two, we are under bivariate analysis now. The two variables there are numeric. Both of them are numeric. It's a scenario that both of them are numeric. There are two possible options. Two possible statistical tools that we can use in that kind of scenario. It's either we are using Pearson correlation or we are using simple linear regression. Pearson correlation, simple linear regression. Pearson, or I don't know the way you pronounce it, Pearson. So Pearson correlation, then simple linear regression. Now, when do we make use of Pearson correlation? And when do we make use of simple linear regression? We know that for both, the variables, they have to be what? Have to be numeric. The two of them have to be numeric before we use it. Now, we make use of Pearson correlation when we are only interested in, is there any significant relationship? Is there any significant relationship? We are treating all the variables there as independent variables. They don't depend on each other. That's when we make use of Pearson correlation. But once we have a cause and effect relationship, that is the impact of what we are trying to find out, the impact of one on the other, we make use of what? Simple linear regression. It's not a regression analysis, where we have a dependent variable and independent variable, because it's bivariate. So it's still two variables. One is dependent, the other is independent. Once you can assert that from your research question, you are using simple linear regression. Let's give examples so that you can understand perfectly. What's the impact of age at marriage on number of children? Age at marriage, what type of variable? Age at marriage, what type of variable? Numeric. Number of children, what type of variable? Also numeric. Good. So this, we're either using simple linear regression or what? Pearson correlation. But then we are looking for the impact of one on the other. That means we are looking at regression analysis. So it has to be what? Simple linear regression. One is depending on the other. Not all of them are what? Independent. We have a dependent variable there. That means we cannot use Pearson correlation. We have to use what? Simple linear regression. Now, look at this one. Is there any significant relationship between number of students and number of hours? So we are not saying that the number of students depends on the number of hours. We are just trying to find out, is there what? A relationship. Like the higher the price, the higher the quantity supplied, the higher the price, the lower the quantity demanded. So that's a negative correlation. When you have the higher the price, the lower the quantity demanded. That's negative. But when you have the higher, that's what? A positive correlation. We can have a positive correlation. We can have a negative correlation. We can have a weak correlation. We can have a strong correlation. We can have a moderate correlation. So we can have a strong positive correlation. We'll go to that in interpretation. But then when do we use Pearson correlation? When we have two numeric variables of which we are only interested in their relationship. We want to know if there is any significant relationship or not. So that is that. Very good. Now let's go into multivariate analysis now, where we have three variables in our research question. If in our research question we have one of them to be numeric and the other two are categorical, like what's the impact of level of education and occupation on monthly income? I think it makes sense. Yeah, education, occupation, then income. Which statistical technique are we going to make use of? Two categorical, one numeric. Why the independent variables are the categorical? Why the dependent variable is the numeric? So which statistical tool are we going to use? We make use of two-way ANOVA. Two-way ANOVA. Why? Because we call it N-way ANOVA. So we have how many independent variables? Two. Yeah, of course, they are categorical. So we make use of two-way ANOVA. But then it can be more than two at times. You can have three, you can have four. So that's why we call it N-way ANOVA, depending on the number of what? Categorical variables, depending on the number of independent variables. So if it is four independent variables and one dependent variable, we call it what? Four-way ANOVA. If it is three independent variables, three categorical variables, and one numeric dependent variable, we call it what? Three-way ANOVA, depending on the number of categorical variables. Okay. So the next one, we can also have another scenario where all of them are numeric. All the variables there are numeric. For example, we have what's any relationship between monthly income, number of children, and okay, let me use this one. What's any relationship between academic performance, cups of coffee, and hours of reading? All of them are what? Numeric. That's it. Academic performance can be numeric when you are considering maybe over 100 or stuff. So, or even if it is in form of CGPA, it's still numeric, 5.0 in all those students. So, what statistical tool are we going to use? Once again, if all of them are numeric, we are making use of either multiple correlation or multiple regression. multiple correlation or multiple regression. But we make use of multiple correlation when we are only interested in relationships. Is there any significant relationship between these three or more variables that are numeric? Then we make use of multiple regression if we have one of them to be a dependent variable and others are what? Independent variables. Don't forget that all of them are numeric variables. That's why we make use of multiple regression. But there's a twist to that. When the dependent variable is not continuous, when it is count, we make use of what we call Poisson regression. We make use of Poisson regression. But then we can also have some circumstances where we have the dependent variable. Take note of this to be categorical. Let's say dichotomous. Let's start with that. The dependent variable is dichotomous. Dichotomous means it is categorical and has only two categories. While the other ones, the independent variables can be numeric, can be categorical, can be both. That is, some of them are numeric, some of them, don't forget we are under multivariate analysis now. The dependent variable, we have only one dependent variable and other, thank God the class is recorded, don't worry, you can always listen to it over and over. One dependent categorical dichotomous variable is categorical and is dichotomous. Of course, when it has only two categories, then it is dichotomous variable. So di means what? Two. But then the independent variables now, they can be numeric, they can be categorical. One of them can be numeric, while the other one is categorical. We don't care. What we just want to know is that the dependent variable is what? Categorical and has only two categories. In that kind of scenario, we make use of what we call binary logistic regression. Binary logistic regression. But then it's also possible that that dependent variable is not having only two categories. Sorry. When the dependent variable is not having only two categories, when it has more than two categories, we make use of multinomial regression. Multinomial regression analysis. When the dependent variable has more than two categories, we make use of multinomial regression analysis as our statistic for that particular question. Either it's business question or research question. But don't forget, there are several factors let me just say there are some factors that affect our choice of appropriate statistic. One of them is the normality of the data. It's possible that data is not normal. When your data is not normal, you don't make use of parametric tests. You make use of parametric tests on normal data. So for data that is not normal, we make use of what we call non-parametric tests. Non-parametric test. So for every parametric test, there is an equivalent non-parametric test. Thus far, all I've been sharing with us are parametric tests. The Pearson correlation, regression. So, but for all of them, if you discover that your data is not normal, you can just search for the equivalent of this particular statistical parametric test for non-parametric test. We can have Kruskal-Wallis, we can have Wilcoxon. We have a host of them like that, non-parametric tests. So, but then I will assume now that our data is what is normal. So that's the assumption I'm making. I just feel that it's important and note that. I'm trying to remember any other statistical tool that, of course, there are so many tools, there's so many of them, but these are the basics. We have ANCOVA, we have MANOVA. MANOVA is when you have two dependent variables. Yes, sir.
At which junction do we use principal component analysis?
PCA is an advanced tool. So we have so many of them. We have CNN. I think I'm currently working on SVM and DA. SVM is support vector machine, but don't let me bring that one in now. I think CNN, I don't even know the name again. I was trying to work on it before. Something has to do with neural network. It's a medical, they use it in the medical field to diagnose cancer, diagnose all these ailments. It's a statistical tool, and we call them algorithms or machine learning tools. So, but then let's still do our data analysis. All these statistical techniques are what they call machine learning algorithms, but they keep on advancing. Some you use them on image data. So image, like brain images or any form of image. So we can use we can use all these algorithms to read them. Data is not only in form of words and numbers. Data can also be in form of images. So don't worry, as we progress, we get to know more. But let's start from the basics like that. So let's start from the basics. There are endless, I mean, of course, they are not endless, but there are many. Let me just use their voluminous statistical tools. Voluminous, very voluminous. So let's stop there for now. I ought to go to interpretation. That is how to interpret. But before going to the interpretation, we need to know how to do the analysis, how to run the analysis first. But I don't think we'll be able to do that today. Then let me also talk about database management. Actually, I will send us a link to a video that we can watch to guide us for the practicals on database management. Then we still treat it online too. I mean, for our weekly meetings. And this actually is what will make my work very easy as we proceed, because this is the statistics part that we need to understand before we start taking up projects. Because I intend to even, at least each of us, three projects before the end of this 3-month training program. Whether you can do the 3 projects in 1 month, anyhow you want to do it. No, but we do three different projects. We need to do 3 projects. Are we together? Please, let's be one out so that we use that to build our portfolios. So that we can say that, okay, we are graduate of data analysis class. Because without a portfolio, nobody will give you a job. Nobody will give you a project to handle. They will ask you that, what have you done before? You may not do this project free of charge without collecting money from anybody. Or you source for funds from another place, use it to do another person's project. Just get it done. The reason why you are not collecting the money is so that they can give you the work. You get it? Because if you want to charge, they will ask you, what's your experience? So that's the strategy. And if you can also use your money, no problem. No problem. So, but it's an extra effort by us. By the time you now start getting the work, you now understand that you need to know this part. It's not just about where is Python. So one needs to get this correctly and properly. Okay, so that's that. Which other thing are we here to discuss? I'm trying to. Any questions? Oh, sorry, I wanted to discuss database management. Okay, the only thing I will let me just brief it. Let me just brief it. The only thing I'll be talking about now is what we call database. We have 2 types of database. We have the relational database and the non-relational database. The relational database and the non-relational database. So then there is what we call structured data and unstructured data. It is possible for your data not to be structured. An example of unstructured data is social media data. Yeah, somebody, maybe Tinubu has Kinecon, That's unstructured data. We can collate unstructured data. Like Facebook now, they have a database of all our posts. That's unstructured. Customers, when they chat, hello, maybe on WhatsApp or something, I need something like this, I need this, I need that. That is unstructured way of chatting, data collection. You can also decide to make it structured, that may be in form of Google form. Any information you fill in Google form is structured because it goes to a CSV file that you can download in form of a spreadsheet. That's structured data. But is that a relational database? No. So you can have a structured data in a what? Non-relational database. So the mere fact that a data is structured doesn't mean that it's in a relational database. Excel, CSV, they are non-relational databases. They are non-relational databases. We have, before we can say that this is a relational database, there's one particular key thing, and that's what we call connectivity. The tables have to be connected to each other. That's when we have a relational database. So when the tables are not connected, we don't have what we call the primary key and the foreign key. Then you are not yet in a relational database. So a good example of a relational database is SQL. SQL. Then we also have Oracle and a host of others. There are always many, like data visualization tools, a host of them. But we are picking out only Power BI and Tableau. And we also refer to them as business intelligence tools. But here now, SQL performs very well. We have MySQL, we have different databases, but SQL is okay, SQL Server. So I will be we'll be looking into learning more about SQL Server in the course of is it 3 months now or less? So that's that. So when we talk about relational database and structured, of course, every relational database contains structured data. Do we understand that? The data has to be structured because it's in form of tables. Once it's in form of tables, then it's structured. But one thing is that don't let us forget that we can have unstructured data. Even CSV file, can we say CSV is structured? Yes, it's structured because it can be in form of table. But you will notice that if you are programming with CSV, at times it's just in form of comma. You just separate each column by comma. So, but then we can refer to it as a structured data. And unstructured data is a data that, okay, I am 6 years old. I live in Oshogbo. The other response, another respondent will say something else. Will not capture a particular area that has been captured by. So it's very difficult to program an unstructured data. Meanwhile, it's easy to program a structured data. The relational databases have told us that the most important thing there is what? Connectivity and security. Security, there is this advantage of relational databases. They are well structured. They are well secured. You can encrypt them. You can password some tables that are like more, like it's not meant for everybody. You can put them in password. Only those that ought to see that part of the data will be able to see it. And of course, you can import data into SQL. You can export data from SQL to do some other things. Then you should know that you should know how to create a database. That's the practical aspect, which I will not be able to do now. You should know how to create a database. You should know how to input data. You need to first create a table inside the database first. So you should know how to now input data into the table. You should know how to, maybe you want to edit a table after you have created it. Like you want to add a column. You want to add a row. You want to do this. You want to do that. We'll be doing the practicals later. But I think the introduction that can come, because I'm not reading with any manual or anything. So let me just stop there for today. I can't remember anything again. All right. So I think it's a nice, okay. All right.
I don't start the information on Microsoft Excel.
Excel is also a very nice tool for data analysis. Excel looks popular but then there are some tools in Excel that we call advanced Excel tools. You can use Excel for descriptive statistics, summary analysis. You can still use them for inferential analysis too. So, but then I'm not sure we have time to start looking into Excel for this training program on the features. But Excel is very good when it comes to data analysis. And I can send those videos on.
So, is it that what, everything can be on Excel, and we want to know this one.
Of course, even more NoSQL, and even Python. Python is everything because it has SQL inside. That is on my SQL and everything. All right, thank you. So let's have a wonderful day.